Assalamu alaikum dear students. We are discussing continuous functions. Now today we are going to discuss algebra of continuous functions. Now suppose if we have two continuous functions, that is f and g, or two continuous functions at a point x equals to a, means x is the common domain point of both f and g, then we have to prove that the sum function or the difference function, that is f plus g or f minus g, is continuous at point A. The pointwise multiplication of these two functions, that is f into g, is a continuous function at x equals to a. F by g means quotient of these two functions is continuous at x equals to a, provided g of a is not equals to 0. And the scalar multiplication of any function, that is of any continuous function, that is lambda f, is continuous at x equals to a, where lambda is a real constant. Since you know that all these four operations, and we can define f plus g or f minus g of x as f of x plus minus g of x. F into g of x, that is multiplication of these two functions, is defined as fx into g of x. F by g of x is defined as fx upon g of x, and lambda f of x is simply lambda f of x. Now it is given that these two functions, that is f and g, are continuous at x equals to a. So this means that by the definition of continuity, limit x tends to a, f of x is simply f of a. This means this limit exists at point a, and the value of that limit simply equals to the value of the function. And this g is also continuous, which implies that lambda limit x tends to a, g of x is simply g of a. Now we have to prove that this f plus g or f minus g is continuous. Now we will simply show that the limit of this function, that is f plus g or f minus g, is equals to the value of the function at this point a. Now limit of this f plus g or f minus g of x is simply denoted by limit x tends to a, f plus minus g of x. Now this equals to limit x tends to a. Now this f plus minus g of x is defined as fx plus minus g of x. Now limit of sum equals to the sum of the limits, that is limit x tends to a f of x plus minus limit x tends to a g of x. Now by the given condition, limit x tends to a f of x is f of a, this means here f of a, and limit g of x, that is this x tends to a, is g of a, that is here g of a. Now f of a plus minus g of a, we can define this as f plus minus g of a. So this means that limit exists for this function, that is some function or difference function, at a point a, and its value is simply the value of the function at this point, that is at point a. So we can say by definition of continuous function, this sum function or the difference function is continuous at this point a. So if f and g are two continuous functions at point a, then their sum or their difference is also continuous at point a. Now the second, that is product, limit x tends to a, f into g of x. Now limit of product for finite functions equals to the product of the limits, that is limit x tends to a. Here f into g of x is defined by fx into g of x. Now limit of product equals to the product of the limits, that is limit x tends to a, f of x into limit x tends to a, g of x. Now limit x tends to a, f of x is f of a, limit x tends to a, g of x is g of a. So this means that f a into g is simply f into g of a. This means that the limit exists and equals to the value of the function at this point a. So limit, we can say that this f into g is also continuous. Similarly, you can prove that the quotient function, this f by g or limit f of x, is continuous at point a, provided this and this g of a is not equals to 0. Now we have to prove that this polynomial function is also continuous at any point, that is it is simply a continuous function. That is we have to prove that general polynomial function or the polynomial is always continuous over entire or means over entire domain. You know that the polynomial is simply an expression of the form of an xn plus an minus 1 xn minus 1 plus so on to a1 x plus a naught. Here the degree of this polynomial is n, means that an is not equals to 0. Now its domain is R, means it is defined at each and every point. So if we consider the point C belongs to R, we will prove continuity of this function, that is p of x at point C. That is we need to show that this limit x tends to C, p of x is p of C. Now limit x tends to C, p of x is simply limit x tends to C. Now p of x is a n xn a n xn plus a n minus 1 xn minus 1 a plus so on to a naught. So simply replace p of x by this. Here this is the polynomial. You know that the limit of the polynomial is simply obtained by replacing variable by the given number. Here given number is c, so we have to replace x by c. It is a n c raised n a n minus 1 c n minus 1 plus so on to a 1 c plus a naught. Now this simply equals to the value of this polynomial at point c, that is p of c. P of c, which implies that limit exists at point c for this p of x, and its value equals to the value of the function at this point, that is at point c. That is limit x tends to c, p of x is simply p of c. This means that this polynomial is always continuous function. So if we have any polynomial and if we consider any point, then it is always continuous function, because this c is arbitrarily point. That is why it is continuous throughout its domain, that is throughout R. Now the second one is we have to prove that modulus function is also continuous. You know that the modulus function is defined by f of x equals to mod x. Its domain is R because it is defined at each and every point. We can define this modulus for any point of R. So this means that its domain is R. Its codomain is also R, that is it is a real valued function. Now we have to prove that it is continuous. Now if we consider any arbitrary point in domain, that is if we consider x equals to a as the real number, that is arbitrarily real number, now we will prove this function is that is modulus function is continuous at this point. Then we can say that this is continuous throughout, because this a is arbitrarily point. That is we need to show this limit x tends to a mod of x, that is f of x is mod of a. Here firstly we will find its left limit and right limit at point a, because for modulus function always find left limit and the right limit. Left limit is limit x tends to a negative f of x, which simply equals to limit x tends to 0 a minus h, because a minus h is a point which is less than a. That is we are approaching to a from left side, that is from the negative side. Now f of a minus h is simply mod a minus h. Now when we put h equals to 0, it is simply mod a. It is simply mod a. Similarly, right limit is limit x tends to a positive f of x, which is simply limit h tends to 0 f of a plus h, because we are approaching to a from right side. That is if we here, if this is a, that is we are taking the value of this function from this side, that is from right hand side. It is simply limit h tends to 0 mod of a plus h. Now replacing h by 0, it is simply mod a. Now which implies that left limit equals to right limit equals to mod a. Also, so we can say that limit x tends to a f of x is mod a. Also the value of this function, that is modulus function, f of x equals to mod x at x equals to a, is simply replacing x by a, that is f of a equals to mod of a. Now this limit exists at point a and its value equals to the value of the function at point a. So we can say that limit x tends to a f of x is f of a. Hence by definition of continuous function at a point a, we can say that this modulus function is continuous at this point a. Since a is arbitrarily real number, so we can say that it is continuous at each and every real number. Hence it is continuous over entire domain or we can say that it is simply a continuous function. So thank you.